Alright folks, welcome back. We're in another Math Notes video here. This is 11.1.3, multiplying and dividing rational expressions. Really the whole first part of chapter 11 is on similar stuff. It's an important concept for us to get down, and let's just dive right into it. So to simplify a rational expression, both the numerator and denominator must be written in factored form. Okay, we can't do any simplifying until we get into factored form. So you're really going to need to remember how to do your area model and diamond problems. Alright, so let's take a look at the first example here. Alright, we have x squared plus 5x plus 4 over x squared plus x minus 12. So first thing we're going to do is factor both of those. For this first one, I'll go ahead and do that with you. So we're going to start with the diamond problem here on our numerator. Remember that the top of the diamond gets a times c and the bottom gets our b term. So a times c is going to be 4x squared. The bottom we have 5x, so we need two things that multiply to 4x and add up to 5x. Well, that should be 4x and 1x. If we do the area model here, we know that x squared goes in the top left, plus 4 goes in the bottom right, and then these two guys fill in the other two spots. So that's going to be 4x plus x, x times what gives you 4x, 4, x times what gives you x plus 1. So this top factors as x plus 1 times x plus 4. And we're going to do the same thing for the bottom. I'll do that in red. So we have a diamond problem. Again, negative 12x squared, positive x, so that's going to be 4 and 3, positive 4, negative 3. X squared minus 12, that's the 4x, the 3x, x plus 3, and what did I forget? Should be minus 3 and plus 4. So then this simplifies to, or factors, to x minus 3 over x plus 4. So when I do that, hopefully I got the same thing we got there. Sure enough, we have x plus 4 times x plus 1 on top. On the bottom, x plus 4 times x minus 3. Well, now we can come in there and put a big 1 right through those x plus 4, because whenever we have an x plus 4 over x plus 4, that'll give us 1, or any number over itself is 1. And they've done that. So now we have 1 times x plus 1 over x minus 3. And the last thing that we need to do is say what x cannot equal. To figure out what x cannot equal, we go back to our factors here, and we ask ourselves, what values of x would make those factors 0? This is zero product property. And it turns out that if x was equal to 3 or negative 4, we would have a 0 in our denominator, and we know that's not allowed, so we have to include in our answer then that x cannot equal negative 4 or 3. So same process for example 2. The top's already factored. Oops. We're going to hope that we end up with a 2x minus 7 as a factor once we do the bottom one. So let's do that off to the side here. I'll erase the last problem so we have room to do that. So on the top of our diamond, we're going to have negative 70x squared, 3x, so we need two things that multiply to negative 70 and add up to 3. Well, I'm not seeing it right away, so I'm going to start making little factors of 70. I'll go 1 and 70, nope, 2 and 35, nope. Let's see, 10 and 7. 10 and 7 looks like it will work. So those are going to be what fills this in. And we need to have the 10 be positive and the 7 be negative. So in our area model now, 2x squared goes there, negative 35 goes there, 10x goes in one of the slots, negative 7x goes in the other slot. I'm going to ask myself, what's the GCF for this top row? 2x can be divided out of both of those, and then from here I say 2x times what gives me 2x squared. That's x. X times what gives me negative 7x, negative 7. 2x times what gives me 10x. That's 5, and then I check the last square. 5 times negative 7 equals negative 35. So that works. So it looks like we can break this into 2x minus 7 times x plus 5, which sure enough they did. And there's our 2x minus 7 that we were hoping for, because that's going to let us do another big one through that. Which then leaves me with 1 times 1 over x plus 5, which we can just write as 1 over x plus 5. And we know that x cannot equal negative 5 or 7 over 2. That's because negative 5 here would make that factor 0, and 7 over 2 here would make that factor 0. If you're confused about the 7 over 2, what you do is you set this factor equal to 0. So you say 2x minus 7 equals 0. Add 7 to both sides, we get 2x equals 7. Divide by 2, we get 7 over 2. So if x was 7 over 2, we would get 0. So here's our final answer. All right, moving on. You can multiply or divide rational expressions using the same method you use to multiply and divide numeric fractions. So if we look at these examples below, we're asked to multiply these two fractions. We know that if we're multiplying fractions, we have a binomial here. I'm going to put parentheses around here just for clarity's sake. A trinomial here. We just multiply across the top and multiply across the bottom. I'll put some parentheses here as well. And because we're just multiplying across the top, multiplying across the bottom, this is almost like one big fraction. There's no cross multiplication here. This came up in class the other day. You cannot cross multiply. That's a way of solving when you have an equal sign between two fractions and you're trying to figure those out. It's not the situation here. So after factoring, we can write this expression like so. So the first step is almost always, again, going to be factoring. And I'm not going to go through all of the factoring on this video here, but you're going to factor each of these as much as you can. So all 4 of those need to be factored. The first one here, you need to notice that they both have an x in common. So you can take an x out and then have x plus 6 left in. If you distributed that x, you'd get back to the original value. This guy right here, the x squared plus 7x plus 6, you're going to have to do the area model diamond problem, break it down to this. On the bottom, x plus 6 squared is x plus 6 times x plus 6. And on the bottom right, you have a difference of squares. So that's x plus 1 times x minus 1. All of those things show up in this problem. And now that we have it broken down into factors, we can start with our big ones, right? So we have an x plus 6 here. We have an x plus 1 here. We have this x plus 6 and this x plus 6 right here are going to cancel, which means that the only thing we have left is x over x minus 1. Let's see if they express that any differently. Oh, and then we would have to say what x can't equal. Well, it can't equal 1, negative 1, negative 6. X cannot equal 1, negative 1, negative 6. All right, they went ahead and reordered it, which is fine. moved it so that you can see the big ones more easily. Big one there, big one there, big one there. Still left with what we have right here. And then that's exactly what we have left again. So there's the final answer. The x over x minus 1 and x cannot equal 1, negative 1, or 6. Example 4, same process. Factor everything. Get into its factors. Look for the big ones and get rid of them. Okay? So factor all of these. Figure out what you can cancel. When I look at that, I have a x minus 5 on top, x minus 5 on the bottom, x minus 2 on top, x minus 2 on the bottom. So that leaves me with x plus 1, and that's the same thing they have here in this next step. X plus 1 times x plus 6 on top, and x minus 2 times x plus 3 on the bottom. I would just leave it like this, frankly, unless the problem specifically says to put it into general form and not factored form, in which case you'd multiply it back out and get that. Okay, and again, x cannot equal on this 5, 2, 2 we already said, and negative 3. So 5, 2, negative 3. If you graph those, you would have holes or asymptotes there, indicating that there's no x value that's possible. Okay, so guys, I have 2 problems for you here. We've got f of x and g of x. I'd like you to first solve one where you multiply these 2 together, and the second one where you divide g of x, or divide f of x by g of x. All right? Give that